The breathtaking images captured by the James Webb Space Telescope are now unveiling a universe that stretches far beyond the Big Bang. Following a series of groundbreaking discoveries, scientists are now suggesting that we may have finally uncovered evidence of a universe that existed before the Big Bang itself. Nobel Prize-winning physicist, Dr. Roger Penrose, has recently proposed a theory that if we look deeper into the mysteries of the Big Bang, we might actually catch a glimpse of a universe that predates it. According to Penrose, the Big Bang wasn't an abrupt starting point as we once thought, but more like a smooth boundary. This opens up the possibility that the universe might continue beyond this boundary, as if space and time didn't begin at the Big Bang but were simply passing through one phase to another. He suggests that rather than inflation occurring after the Big Bang, it may have actually taken place before it. These new discoveries from the Webb telescope are beginning to prove that the origin of everything did not start with the Big Bang alone. In 1921, scientists first discovered that our universe is continuously expanding by observing the movement of galaxies. However, the expansion of the universe isn't as straightforward as it might initially sound. To better explain this, think of a blank sheet of paper that extends infinitely in all directions. This sheet represents the fabric of space. When scientists say the universe is expanding, they mean that this fabric of space itself is stretching and growing larger. Now, imagine placing two galaxies on this expanding sheet. As the space stretches, these galaxies appear to move away from each other. If you place a third galaxy elsewhere on the paper, you'll notice that all three galaxies seem to move farther apart from one another. This shows that there isn't a single central point from which the expansion starts. Regardless of where you are located in the universe, it will always appear as though you are at the center because everything around you is moving outward. The farther away a galaxy is from us, the faster it seems to be moving, which indicates that space itself is not only expanding but that its expansion is actually accelerating over time. Scientists have observed that if we consider Earth as the center of the universe, there is a particular distance at which space begins to expand faster than the speed of light. But don't worry, this doesn't violate Einstein's rule that nothing can travel faster than light. Einstein's rule applies to objects moving through space, not to space itself. What's happening here is that space itself is expanding at a rate faster than the speed of light, which is perfectly allowed by the laws of physics. This fascinating aspect of the universe's growth has led to the concept of what is known as the Hubble sphere. For centuries, humans have been observing the universe using telescopes, and everything we have ever observed exists within a specific region of space known as the Hubble sphere. This sphere is about 48 billion light-years in diameter. All of the most distant galaxies that have been discovered up to this point exist within this region of the universe. While these galaxies are moving away from us, they do so at a speed slower than the speed of light, which allows their light to still reach us. Some light from galaxies beyond the Hubble sphere began its journey toward us billions of years ago and will eventually reach us, expanding our view of the cosmos. As the Hubble sphere continues to expand, we are able to see deeper into the universe, allowing us to observe more distant objects as time goes on. However, the Hubble sphere will not keep expanding forever. There are galaxies that are so far away that they are moving faster than the speed of light, and their light will never be able to reach us. This limitation creates what is known as the observable universe. The observable universe is roughly 93 billion light-years in diameter, and it represents the boundary of how far we can see. Although there are certainly countless galaxies and stars beyond this observable boundary, we are unable to detect them. What makes the universe even more fascinating is the fact that when we look at distant parts of it, we are actually looking back in time. This happens because light takes time to travel across space. For example, if we observe an object that is 1 light-year away, we are seeing it as it existed 1 year ago. The farther we look into space, the farther back in time we are seeing. So far, scientists have been able to observe over 13 billion light-years into the early universe, using advanced and powerful telescopes. From these observations, scientists have created a standard model of the universe, which outlines what the universe looked like at various stages in its history. For example, when we look more than 13 billion light-years away, we are seeing a time in the universe's history called the Dark Ages, when the cosmos was filled with dark clouds of hydrogen gas. According to the standard cosmological model, if we could observe the very edge of the observable universe, about 13.8 billion light-years away, we would be witnessing the exact moment of the Big Bang, the event that gave birth to our universe. Scientists believe that at the beginning, the universe was compressed into a singularity, an unimaginably tiny and dense point. However, we don't know exactly what this singularity looked like because our current scientific theories break down when trying to describe it. Recent observations from the James Webb Space Telescope have called into question the long-held belief that the Big Bang marked the beginning of everything. Evidence is now emerging that suggests a strange universe may have existed before the Big Bang, and these new observations strongly support this idea. One example is an incredible image captured by the Webb telescope showing the light from a supernova that exploded 10.2 billion light-years away. Due to a phenomenon called gravitational lensing, this supernova appears in 3 different locations at once. Scientists are studying this supernova to measure the speed at which the universe is expanding. Surprisingly, the latest measurements show that the universe is expanding even faster than previously believed, hinting that this expansion may have begun before the Big Bang itself. This idea is also supported by Dr. Roger Penrose, who believes that the expansion of space began long before the Big Bang. Penrose challenges the traditional inflationary model, which states that exponential expansion occurred immediately after the Big Bang. He suggests that this expansion was already in place before the Big Bang, reshaping our understanding of the cosmos. The James Webb Space Telescope has also detected galaxies at previously unreachable distances, many of which defy predictions made by the Big Bang model. Some of these newly discovered galaxies appear to be more massive, more structured, and more developed than the model would allow for such an early period in the universe's history. One remarkable discovery was the detection of light beyond the so-called Dark Ages, a time when we shouldn't be able to observe anything according to current cosmological models. This has led scientists to rethink some of the foundational principles of cosmology. If these findings are confirmed, they could forever change our understanding of the universe. Instead of the Big Bang being the absolute beginning, it may simply be a phase in an ongoing, perhaps infinite, cycle of cosmic events. These new observations suggest that the universe may have had a history before the Big Bang, a concept that challenges the very core of modern cosmology. If proven true, these discoveries will not only reshape our understanding of the cosmos but also open up entirely new realms of scientific inquiry into the nature of reality itself.